Alright, today we're going to do the perfect squares and square root notes. So our learning target is I can determine the square root of a perfect square equal or less to 400. Alright, so we're just going to start with this. And what we mean by this, you can see the exponent here. This exponent, I'm going to zoom in just a little bit. There we go. This exponent tells you how many times we're multiplying the base number. So this is really 1 times 1, which we know is 1. And that's when I think of a 1 by 1 square, where my area here would be 1. Let's do the next one. So the next one, my exponent here, and with all of them, is going to be 2, because we're squaring. So this is a 2 by 2. That's what that means. And 2 to the second power, 2 squared, is 4. And we can see that here if I draw a 2 by 2 square. So this is 2 by 2. And we see that it equals 4. So if I say I'm taking the square root, that's what that symbol is, of 4, it equals 2. When you take the square root of a number, it's telling you what the sides would be if I made a perfect square out of that many little squares. So out of making a square with 4 squares, my side lengths would be 2 and 2. So these are the perfect squares. Those are the perfect squares. So let's look at the next one. This one is going to be a 3 by 3. 3 times 3 is 9. So we notice there are a couple numbers in here that aren't perfect squares. 5, 6, 7, 8. None of those are perfect squares. So what we mean by that is, let's say I take 6 squares. If I have 6 squares, that's a 2 by 3, which is a rectangle. Because we know squares have to have the same side length on both sides. Equal side length, that's what makes a square. So if I have 6 little squares, I can't make a perfect square. I can't do it. It's always going to be a 2 by 3. And that's why it's not a perfect square. That's why I need an additional 3 squares here. If I had 7, that doesn't work. Here's an 8th square. That doesn't work. But if I had 9, I can make this a 3 by 3. And that's where that perfect square comes in. So that's the idea here. So let's do the next one. 4 squared. 4 times 4 is 16. 5 times 5 is 25. 6 squared. 6 times 6 is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. So those are probably the ones that you know. You might even know up to 14. We're going to get all the way up to 20 squared. I'm going to move this over a little bit. There we go. I'm going to start writing them on the diagonal just so I can fit them all because they're bigger numbers. So 11 squared, remember we're talking about 11 times 11. So if I made a square that was 11 blocks on this side by 11 blocks on that side, the total would be 121. 12 by 12 is 144. 13 by 13 is 169. 14 by 14 is 196. 15 by 15 is 225. 16 times 16 is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And finally 20 squared is 400. And this should be one that you should know too, because if I think of 20 times 20, I know I do 2 times 2 is 4 and add those 2 zeros. So that easily gives me 400. So if you're ever not sure what a number is squared, you can always do the multiplication. And there's one thing that's kind of cool. So if I think about when I'm looking above 10, because those are the ones you might not know as well, if I look at this last digit, the digit in the ones place for each of these numbers, it actually helps me determine what the square root would be. So if I'm trying to think of the square root of 144, I'm going to think about this 4. I'm thinking, what two numbers when I multiply them together, will give me a 4. So if I think of it, if I'm looking at these guys, 1 times 1 is 1. 2 times 2 gives me a 4. I know it's bigger than 10, so I have a possibility of it being 12. Times 3 is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. There's another 4. So it could be 18, because 2 times 2 or 8 times 8 is going to give me that final digit. Right? Because both of those numbers, if I do 12 times 12, I'm going to end in a 4. If I do 18 times 18, I'm also going to end in a 4. So that's how I kind of get down to 2, by thinking of that last digit. Now, the last part I think about, so I think about this middle here. This is the middle. In between 10 and 20 is 15. That's just the middle of 10 and 20. So I think about, is this number here, this square root, bigger or smaller than my middle? Well, 144 is smaller than 225, so it can't be 18. It's got to be 12. So that's just a little trick, thinking of that last digit and what number times itself is going to get me there. That's a little trick. Let's flip over and look at the square roots. So this is a little about what we talked about on the front. Okay, so let me zoom out for a second so I can read this. So this is the square roots and perfect squares can be represented geometrically using shapes as the length of a side of a square. So what perfect squares and square roots do they represent? So this is kind of what I was talking about on the front when I was drawing those squares. So if I look at this one, let me focus that, there we go. This is a 2 by 2. So this is 2 squared. I'm going to put the little 2 up there because it's really kind of in the wrong spot there. 2 squared, 2 times 2, which equals 4. That's the total number of squares here, right? 1, 2, 3, 4. So the square root of 4, if I make a square with 4 little squares, my side length is going to be 2. The square root of 4 is 2 because 2 times 2 equals 4. So let's look at this one. This is a 1 by 1. 1 squared, again I'm going to get rid of that. 1 squared is 1, so the square root of 1 is 1. Let's look at this one. This one is a 4 by 4. 4 squared. 4 times 4 is 16. And I could count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the square root of 16, I make a square where I'm doing a 4 by 4. That's what it is. The square root of 16 is 4. So I'm going to make a square with 16 squares. My side length would be 4. Let's look at these last couple U-tries. So these last couple, I'm going to look at my last digit here. This is a 9. Okay, so what numbers are going to get me to a 9? 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So this could be 13. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. So this could be 17 because both 3 and 7 are going to get me that 9 in the ones place. So now I think, is it bigger or smaller than that middle, that 225? Well, 289 is bigger than 225, so this one must be 17. Oh, here's an easy one. We already talked about the middle being 225, so that one's 15. 18 squared. 8 times 8 is 64, so I know it ends in 4. Okay, and these are just ones you have to memorize. You need to memorize your perfect squares. This one is 324. If you do it out and multiply it, that's fine, but we do really want you to memorize these. This one, 3 times 3 is 9, so I know it ends in 9. 13 times 13 is 169. So these are the square roots and perfect square notes. Feel free to play them again if you need to.